Okay, so, and these, what I've got here, which are not hand-drawn, right, this is copied from the test. This is the directions on the test. Sketch the graph, including the asymptote. It's going to be an exponential, right? So it's something like this. So it's very much like the quiz question that we just had. Again, this is exponential growth or decay? It's growth, right? Because it's, this 2 is great. What's that? Yeah, because this is greater than 1 because that's a positive x, then it's going to be growth, which we know means that the graph would look like something like that, right? But what's the effect of adding 1? Left 1, right? So if I take an exponential growth model like that, which has an asymptote here, and I move it to the left 1, does that move the asymptote? No, because the asymptote, it's a horizontal line. If you moved it to the left or the right, you wouldn't really see the difference, right? It's the same thing. It would move the intercept, which used to be at 1, will now be at -1, 1. It moves that to the left 1. But the graph, other than that, the graph looks pretty much the same, like that. Right? The second one, is that growth or decay? That's decay, right? Because of the negative and the exponent, the negative in front of the x, that's going to be a decay. So again, I would expect that the graph looks something like this. It would have an asymptote, which is on the x-axis. What's the change in the graph because of the -3 after? It moves the whole graph down 3. So we're going to go 1, 2, 3. There's our new asymptote. Okay. We had a y-intercept at 1. Now that y-intercept is at -2. It will move down 3. But the shape of the graph is still, it's exponential decay. It's always 1. I mean, just think, on the y-axis, x equals 0. If I put in x equals 0 here, then, I mean, without the -3, then it would have been 2 to the 0, which is 1. Yeah, substitute x is 0, solve for 1. And then, because of the -3, 1 minus 3, -2. Okay, so you have to understand when you sketch these graphs that the calculator may not show you exactly what you want. I think we had a lot of, on this kind of problem, maybe it's on the quiz that we just took, that it looks like it touches the x-axis. It really doesn't. That's just the calculator display showing that. You got to know more than that. Don't show it stopping. It keeps going forever. Right? Remember, the domain of this thing is all real numbers. It does not stop.